All right, so these are the vertex forms of all the kinds of functions that you're gonna need for these guys. So I'm gonna do I. Hopefully you have a picture of it because you're probably not gonna be able to see it. So I. This is my first piece, which is going from negative infinity until 1, 2, 3, 4, 5, 6, 7. So this is x is less than or equal to negative 7. Then from negative 7 to negative 3, so negative 7 is less than or equal to x is less than or equal to negative 3. It's going to follow this rule. And then it's going to go to negative 1, so negative 3 is less than or equal to x is less than or equal to negative 1. And then it's going to go to 1, 2, 3, 4. So negative 1 is less than or equal to x is less than or equal to 4. And then it's going to go to 9. So 4 is less than or equal to x is less than or equal to 9. And then x is greater than or equal to 9. So when I'm looking at these, just give me a minute, but when I'm looking at these, this one is going to be absolute value. So I'm going to look for the vertex on this guy, which is at negative 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. I'm going to plug that in to the rule. So a x minus negative 5, so plus 9 plus 5. I got to figure out what a is, so I'm going to use any point on here that's not on the vertex. I'm going to use this point right here, which is at negative 7, 10, negative 7, that point right there. I'm going to plug that in, so I'm going to go 10 equals a negative 7 plus 9 plus 5. 10 equals a. That gives me 2. Absolute value of 2 is 2 plus 5. Subtract the 5. Divide by 2. So this rule is going to be 5 over 2 x plus 9 plus 5. Next row is a quadratic. I'm going to do the same thing. This vertex is at negative 5, 6. So I'm going to go and then I'm going to figure out what a is by using any other point. This one's at negative 6, 7. It's going to give me negative 1 squared is 1 times a. Subtract the 6, so I get 1 equals a. So I'm going to plug that guy in. So it's going to be x plus 5 squared plus 6. This one's going to be linear. It has a slope of, it goes down 10 and over 2. So it has a slope of negative 5. And it's going to go down another 5. It's going to have a y-intercept of negative 5. This one's a square root, so it's going to be has a vertex of negative 1, 0. Use any other point on here. I'm going to use the point 1, 2. So this one's going to give me a slope of 2 over the square root of 2. Rationalize the denominator. 2 square roots of 2 over 2, which really just means it has a slope of the square root of 2. So it's going to be square root of 2 times the square root of x plus 1. When you have square root and square root, you can actually distribute. So I would distribute this to make it really just square root of 2x plus 2. This one right here is an absolute value, but it's upside down, so I know it's gonna have a negative. Has a vertex at 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Absolute value, so it's f of x equals a x minus 7 plus 6. Pick any other point to put in here. I'm going to use this point right here, which is at 1, 2, 3, 4, 5, 2. So 2 equals a times absolute value, 5 minus 7 plus 6. Subtract the 6. It gives me a 2. I'm going to divide it. So a is negative 2. So it's going to be negative 2 x minus 7 plus 6. And the last piece is a constant at 2. So that's the whole rule for this one.